For a given reaction at a given temperature, the reaction quotient reaches a constant value. That reaction quotient Q, we're going to define that in just a little bit. That reaction quotient, you calculate that from what we call activities of the species that are involved in the reaction. A species is our generic term for either an atom, an ion, or a molecule that's involved in a reaction. Okay? So for every reaction, there's a thing called a reaction quotient. It's a number that we can calculate, okay, which depends on the activities of the particles that are involved in that reaction, okay. Now, for a precise definition of what activity is, you're going to have to take an advanced course in chemical thermodynamics, and that's physical chemistry. And I teach that in the fall, actually in the spring, okay. So, but we're going to simplify things at this level. We're just going to say that these activities these are unitless quantities, by the way. We'll just approximate them. These activities are related to concentration and pressure, and so we're at this level. We're just going to say if we're dealing with a pure liquid or a solid, the activity is 1. Okay. If you're dealing with solutes in dilute solution, then the activity is just the molality. Now, since we are going to be doing mostly aqueous solutions, remember, if you have a very dilute aqueous solution, molality is essentially molarity. So for our purposes, we're just going to be using molarity as our activity. Okay, so pure solid or liquid activity is 1. Dilute aqueous solution, the activity is the molarity. It's just the numerical value, okay, no units. If you're dealing with a solvent in dilute solution, the activity is the mole fraction of the solvent in your mixture. And that's going to be essentially 1 for most practical purposes. Since we're going to be dealing with aqueous solutions, dilute aqueous solutions, we're just going to say we're going to just use 1 for our solvent. So the activity of water in a dilute solution, we'll just say is essentially 1. And if we're dealing with a gas, then the activity will be just the numerical value of the partial pressure in atmospheres. Okay? Actually, the modern standard, the modern definition is you have to use bar, which is 1 atmosphere is 1.01325 bar. Okay? So that means you're about 1% off. But most general chemistry textbooks still use atmosphere, so we're going to stick with atmosphere. Okay? But if you do get to physical chemistry, our activities for what we call an ideal gas case would be the partial pressure, the numerical value of the partial pressure in water. Okay. So here's a quick question. If you have 0.01 molar barium chloride solution, what would be the activity of chloride ions? In other words, what would be the molar concentration of chloride ions? Okay. Remember, the brackets mean concentration in moles per liter, right? So what's the numerical value of the concentration of chloride ions in a 0.010 molar barium chloride solution? Is it A, 0.010, and so on? Okay. Let's go ahead and do a poll. Okay, correct answer. What did we say activity was? It's a unitless quantity. It's for solids. In aqueous solutions, it's the numerical value of the molar concentration. So which one can you rule out right away? No unit, right? So this one, oops, that one's wrong. Okay, what's the concentration of chloride? What happens to barium chloride in water? It breaks up into barium ions and 2 chloride ions, right? So if you have 0.01 moles of barium chloride, that's actually 0.02 moles of chloride. So 2 times 0.01 would be 0.02. Very good. Correct answer is C.